Hi, my name is Kalle. I work at Peltarion as Head of Knowledge Center.
Hi, my name is Gabriela, AI Research Engineer at Peltarion.
Yeah, we're going to talk about early stopping, what it is, and how to use it on the Peltarion platform. So, Gabriela, what is early stopping?
Yeah, so early stopping is this feature we recently added to the platform that enables training to be stopped whenever a specific metric is not improving anymore.
Yeah, because deep learning, it's all about training a model to make really good predictions. And you do that by throwing a large chunk of data on a model and let it train on that and throw it on again and again and again and again. And hopefully the model gets better over time. So, Gabriela, why do you need early stopping if the model gets better over time?
Yeah, we need early stopping because we often want to avoid overfitting.
Yeah.
So early stopping in this sense is a sort of regularization. So what do we want to achieve when training models? Often we want to solve a task, and for that we use training data so that the model learns relevant patterns to solve that task. But actually the core goal is often not to perform well on the trained data, but to perform well on a held out set.
Yeah, new data, live data from the real world.
Exactly.
Yeah.
So early stopping as a regularization method helps us achieve that by avoiding overfitting.
So how does it work? How do you work with early stopping?
Yes, so here you can see, for instance, an example of an experiment in the evaluation view, and that's the loss curve for this experiment. Here you can see that the validation loss, reached a plateau, so it stopped improving, and therefore this particular model was already stopped on epoch 15.
Yeah.
So this is an example of an early stopped model. But if you want to use early stopping for your own models, here in the modeling view, we will see an example, for instance, for a digit classification experiment. And here among the settings, you have first the number of epochs, which is by default 100.
That's quite a lot.
That's a lot.
Yeah.
Yes, we have increased the default number of epochs because we have early stopping now as a feature. So it will continue training as long as it has a reason to. Otherwise, it early stops. So this is the default. The default number of epochs.
Apart from really big models like BERT, that you only train for a small amount of epochs, right?
Exactly.
Because then it doesn't make sense really to have an early stopping.
Yeah, BERT is an uncommonly large model, and it usually takes more time to train.
Yeah.
And therefore we have we set the default number of epochs for BERT to be 2 when we are creating this experiment via the wizard.
Yeah.
Yes, and then right here under you can then find a checkbox called early stopping, and here it will be enabled by default.
Yep.
And you can disable if you want, or let it enabled. And then it has 2 fields. So the first field is the patience, which is the number of epochs without improvement, after which the training will be stopped. So this means that the larger the patience, the more time it will wait until an improvement kicks in.
Yeah. And the default is 5.
And the default is 5, exactly. And here is the metric. That's the metric that the early stopping is going to keep an eye on to see if it is improving or not. And the metric we have is the validation loss for now, but we will add further metrics in the future here. Yeah.
So apart from overfitting, why do you want to use early stopping?
Yeah. So I will run this experiment. Why do we want to use early stopping? So because other benefits are that we can avoid tuning of the number of epochs. For instance, when experimenting with machine learning models, we often don't know beforehand how many epochs we need to train that model for. It's very specific to the model we are to the problem we are solving, and so it's much better to let a mechanism such as early stopping define dynamically until when this training procedure should run, instead of hard coding the number of epochs from beginning. So this is one benefit. Other benefit is that it saves time, and by saving GPU hours, it also saves money.
Yes, because GPU hours can be expensive.
Yeah. Exactly. And finally, this is a kind of feature that is agnostic to the model you're using, to the data type you're using, to the problem type you're solving, to the problem you're solving. So you can use early stopping in any problem.
So how do you know that the experiment has been early stopped?
Yeah. Yes, there is this sign over here.
Yeah.
This is a gray square that shows that an experiment is early stopping. This one we started is, for instance, still running.
Yeah.
But here in the modeling view, we can also see here.
Yes.
The experiments that are early stopped. Even in the cards, we can also see the experiments that are early stopped, the ones that are still running.
So this is a really helpful feature. So you don't have to work so hard to set how many epochs you want to run hard coded. You can basically set a high number and then let it see if the model improves, and then it stops. If it doesn't, then it would stop by itself. It's really good.
Exactly. Yeah. Yes, exactly.
So if you want to read more about early stopping, head over to peltarion.com/knowledge center, where you can read more about early stopping and all the other features on the Peltarion platform. Also do some tutorials. But you always learn best if you try it out yourself. So I strongly suggest that you head over to our sign up page, peltarion.com/signup, and sign up for a free trial of the Peltarion platform. Okay, so thank you and goodbye.
Thank you.